Recorded is rolling. Today is Wednesday, August 24th. I have this lab lined up for you guys. Now, before I dive into that, uh, remind you, so I did see you guys last couple days. One of the pages I handed out to you guys was this page right here. Right. Who does not have this? Maybe you weren't here either last few days.
I don't remember games.
You guys know. One, two. There you go. All right. So I have not told you guys how to solve any of those problems yet. I'm just getting this page in your hands early. So if you want to look at it or see how it works. Okay. But here's your you guys' homework assignment, but it's not due for quite a while because again, I haven't shown you guys how to solve those yet. Okay, so pick up planner from the cafeteria. How many guys picked up your planner yesterday at the cafeteria? All right. So you got to a good start. If you picked it up, guys, use that planner. It'll help you out in your classes. It'll also help you out in your personal life, just any goals you have, whether for your classes or your own life. Put your planner, make a space and time for it. I promise you that will help you out. Um, these other couple bullet points, right? So linear motion problem solving class and then 20 conceptual questions. Those both refer to this paper, opposite sides. So some of these are going to be equation type problems. I'll do some of these in class as long as you follow along. It'd be just like some past papers where we all have different numbers, but all the same scenarios, right? So it might be like dropping a ball off a cliff, but maybe my cliff is different height from your cliff. Okay? And as long as you follow along with me, we're not doing this today, but in the future. Okay? And then on the other side are 20 conceptual questions. Now, this we're gonna more focus on with you guys for conceptual physics. So I'll go over these questions and answers with you guys someday. Just make sure you follow along the day that we do these, and then eventually I'll pick up this page from you guys and give you guys some credit for that. Okay. Also, just to get further down the line, I'll eventually get you guys quizzes, and the quiz for you guys is going to mostly focus on those conceptual questions, and then there might be some calculation problems. Okay, guys, good so far? All right. So now this lab right here, I'm gonna have you guys. We're going to linear motion, and we're gonna kickstart linear motion with this lab, so you guys can actually get your hands on these materials and see how this works, measure some values, and then later on, as the class is going on, we're eventually going to put together these equations right here. Right? So that's where this is all heading, just one step at a time. Okay. So you guys see some Hot Wheels cars back there. Do you guys think what variables could possibly affect the motion of the car going down the incline? Okay. Ooh, do you think the mass of the car might possibly affect the motion? Like if you double the mass of the car, that might make it maybe faster, slower, or maybe no relationship. Maybe it doesn't affect it. I don't know. It's an open question. Right. How about this displacement x? Okay. Now the further the car rolls, if you're changing this distance, right, here's like the finish line down here. Okay. Do you think it takes more time to roll a further distance? Yeah, okay, that's pretty obvious. But maybe what wouldn't be as obvious is what exactly is that relationship? Like if you double the distance, would that also double the amount of time it takes to get to the bottom? How do you guys think if you double the distance from like 100 to 200 centimeters, it would also double the amount of time? Okay, so that would be a linear relationship. They may or may not be the case. So think about that one. How about the speed of the car at the bottom? Right, speed of the car. Now the measuring tool you guys are using for speed is going to be this speed gate right here. Okay. Look at that. That's that right there, isn't it? You guys see the same thing? Okay. Show you guys how this works real fast. So it's got a couple of sensors on it. So anything that runs past these two sensors, it'll do that distance divided by the time, and it'll get spit out a speed in meters per second, kind of like miles per hour, meters per second. Right, for example, 0. Okay. 0.03. Okay, let me try again. Start over. And 2.56 meters per second. 2.56. Try again. Come on here. 3.01 meters per second. All right. So works sometimes. There you go. And time, stopwatch. Did you guys bring your cell phones today? You guys got a stopwatch function on your cell phones? So that could be one of your tools. Do you think the angle of incline has something to do with it? Like if this is a really shallow incline, the car might kind of slowly meander down versus if it's a really steep incline, the car's was down. Right now, that's going to be one of our control variables. So everybody has the incline already set up at 5 degrees. We're going to control for that. Okay. All right. Do you guys got some paper up? You guys got some paper? If you don't have any paper, then here's a stack of paper right here. So you can either get your own paper or grab one of those. I just right on that is. Do you guys see a playing card on your desk? Do you guys see a playing card? So you either have a spade, a diamond, a heart, or a club. You guys see that? Yeah, one of those suits. Right now, I'm going to split you guys up into different groups to run this experiment. Now, why are we doing that? Back up a little bit here. Because in ideally in an experiment, you want how many different independent variables at a time? One, right? You just want to change one thing at a time, right? And then how many dependent variables do you want at a time? Just also one at a time, right? You want to control everything else. For example, like this is way too many variables to be juggling around. Like, how do you figure out this whole complex relationship? I mean, I see a ton of variables, right? Well, you want to control for a couple of those, and then change one yourself, and then see how does some other variable respond, right? And break it down into exactly these 4 experiments right here. And so if you have clubs, copy down this table. If you have diamonds, copy down this table. If you have hearts, copy down this table. If you have a club, or what is it called? So spades is this guy, diamonds is this guy, hearts is this guy, and clubs is this guy. Okay? Okay. So while you guys are copying that down, let me tell you what you're looking at so you can process this information. Okay, so if you have the spades, you're going to say, how does the mass of the car affect the rolling time? Okay. So there, if you just use a blank car itself is about 30 grams. If you want to get a more exact value, there's some scales back there. There's a triple beam balance, there's a digital scale. Put the car up there, an empty car, it's pretty close to 30 grams. Then to change the mass of the car, do you guys think you take some of these lab weights and this masking tape and tape these weights onto this car? Right? Now, you only care about changing the mass if you have the spades. If you have anything other than the spades, do you care about the lab weights and the masking tape? No, only the spades, because everybody else is going to control for the mass. Right? Okay, so you change the mass of the car. So I have different trials going on. Or you guys gonna have different trials? Anything? Hey, how about distance? Are you going to roll the car the same distance every single trial? If you have the spades, yes, you are controlling for the distance. So 200 centimeters might be a good distance, right? Over and over. You would be changing the mass of the car. Think about that sort of like your independent variable, right? You're changing the mass, right? And then you're gonna say, well, how much time does that take? See what mass versus time, right? So how much time does that take? Right? Click from beginning to end. What I want you guys to do with the, especially anytime you deal with the stopwatch, is to run, say like 3 times and take an average. Can you guys do that? Do like this car 3 times and take an average, then tape on some math, do these three and take an average, then tape on some more math, do 3 and take an average. You guys do that? You do that, right? Okay. Now, I'm only showing 3 trials here because I'm trying to fit everything onto one page so you guys can see the big picture. But really, on a graph, you'll want at least 5 data points. So see how I have like trial 1, trial 2, trial 3? How many total trials do you want? Minimum trials. What do you guys think? I just told you. 5. Yeah, 5. All right. Now, if you have the diamonds, let's see what you're doing. Okay, so you have different trials, trial 1, trial 2, trial 3. Okay. The mass of the car, or if you have the diamonds, are you leaving the mass of the car the same all the way down? Yes, because this will be a controlled variable. It'll be controlled, right? So same mass all the way down. Okay. Will you be changing how far the car rolls? Yes, because x versus t, think about x kind of like your independent variable, right? You might go 50 centimeters, 100 centimeters, 150 centimeters, 200 centimeters, right? You're going to be doing different rolling distances. And then you're going to pick up your cell phone stopwatch, and you're going to say, how much time does that take? Do 3 and take an average, 3 and an average, 3 and an average, right? Can you do that for at least 5 different data points, right? Now, if you have the diamonds, I did throw in one more column, which is to square those times. So whatever the average time is, square it. That probably doesn't make sense right now, but that'll make sense tomorrow when we start to put the graph together. Okay? If you have the hearts, you're probably most of the way through copying this table. So different files. See mass. Are you leaving the mass the same all the way down? Yeah, because mass is again controlled. V versus T, you have different speeds, different times, but you want the mass to be the same, right? Uh, okay, so how long could it take? How much time? Now, the way you can get different rolling times is you do have to have different rolling distances. So you let the car roll at different distances. But notice on the hearts table, I did not actually give you guys a column to mark those locations because you're just going to measure how much time does it take. Okay, you guys get that idea? Okay, so yeah, you started the car at different places, but you're not going to record the distance. You're just going to record the time. Okay. Now, different distances will give you different times. You do care about that. You do care about different times. And then you're going to use your speed gate, which is this guy right here that I just demoed for you guys. Let the car roll through, and then get those speeds. Right? Ooh, do you think you could do like 3, take an average, 3, take an average, 3, take an average? Could you guys do that? Right? And finally, if you have the clubs, V versus X. Now, actually, the hearts and the clubs is a very similar setup. If you were just like watching somebody just like off from the side, it'd be hard to tell the difference. But the difference is that instead of timing it, and notice there's no stopwatch on the clubs table. You guys see time in seconds? No. I want you guys to measure the rolling distance. You can do centimeters or meters, centimeters or meters. Okay, as long as you're consistent all the way down. Okay. Then similar idea. Let the car run through the speed gate. Do 3, take an average, 3, take an average, 3, take an average. And I did throw on one more column, which will make sense when we crunch the stated tomorrow, which is to square those speeds. Right? Okay. Is that all right? Any questions about this? Yeah, go ahead.
So, in the diamond one, it says time average, right?
Time average, yeah.
How is it supposed to be average if there's just one?
Okay, so what you do here? So suppose you have the diamonds. What you do is so X versus T. So you will let the car roll different distances. Let's say like 50 centimeters, 100 centimeters, 150 centimeters, 200 centimeters. Okay, those could be different distances, right? Right. Then say you do 50 centimeters. You'll do 50, 50, 50, and you'll get times. Say you get like 1.1 seconds, 1.2 seconds, 1.15 seconds. Okay. Then out of those three, you take it at that average. Right? Then you'll back up the cart to 100 centimeters. Then you run 3 trials at 100 and then take an average. And then you do 150 centimeters, do 3, take an average. Okay. What other questions you guys have? That was a good question. Any other questions? Okay. Do you guys have those tables copied? Okay. I'll just leave this on the projection. You guys remember this is your lab setup. Right? Looks like this. The card just rolls down, start from rest, drop it. Okay. So everybody can use the speed gates at least for fun, but if you have the hearts or the clubs, you definitely need this as a measuring tool. But if you have the spades or the diamonds, you can use it for fun. Okay. Yeah, everything you need back at the lab table. I'm gonna walk around, help you guys out, and in case I don't do an extra recording at the end of class, these are 4 of the 6 graphs we're going to eventually do tomorrow. So by the end of today, you might have a spare 5 or 10 minutes. One class we didn't have time because of the fire drill, but another class we had a spare few minutes. So students could start to make graphs. Okay? For example, if you see X versus T, isn't that going to be like X versus T? If you see M versus T, it's not M versus T. B versus T, B versus T, B versus X, B versus X. Is that? So yeah, close to the end of the class, I will throw this on the projection so you guys can start making some graphs. And then tomorrow we'll finish putting the graphs together. We'll analyze those graphs, come up with some equations, and that will lead eventually to these kinematic equations, which is going to help you answer all those homework problems that I will also help you guys out with. All right, everything you need back in the lab table, I'll work around, help you guys out.